we isolate for precipitate in a way that it's kind of accurate? Because when you have the precipitate, it's just floating around in the solution, okay? So the steps to do this. First thing you do is you measure a precise sample of the limiting reagent. Okay, so that's the sample. Now, the sample's coming in a solution formula. How do we measure with great precision how much of a solution? What tool do you use? A pipette, yes. So you use your pipette and your pipette bulb or these things. Now I am pretty sure I stole this from somebody's drawer, so if you're missing one, this is yours. The next thing, add the access reagent to the limiting reagent. So, in your lab, what you will be doing is, well, I'll just show you after we do all of these. Allow the precipitate to settle. Now, in your instructions, I tell you to add about 60 mils of the excess reagent. That will be enough, but to allow it to settle, you have to wait about like an hour. So we won't do that. Just trust me that the amount that I tell you that puts in is enough to precipitate it, okay? Normally, though, we'd allow it to settle, and then we add a medicine dropper to slowly drop it in with more excess reagent until all precipitate is complete. When no new cloudiness forms, then the reaction is completed because you're not making any precipitate more, so it means it's like all being used up. Do you guys kind of get that at all? It's kind of a weird concept, but filter out the precipitate using filter paper and a funnel. So in your textbooks, turn to page 802. Now, they explain it in several steps, and I want you to write them out, but just put it in your own words. You don't have to write down every single word in those steps of filtration. But first, I want to show it to you. So come up to my lab station, and I'll show you what I'm talking about. Okay? Can you hit the pause button there? Or the stop?